Thank you. One of the dreams of Picasso was to paint with light. He used a very small light source to draw a figure in the air, and when he took a camera with a long exposure time, he could get this kind of light pictures. But afterwards, in this room, nothing remained. Can we now imagine a paint that when we draw, for example, a light bulb, this light bulb would really give light? Or when we draw or paint a computer, this computer would really work as a computer? Well, to come to this kind of paint, in our lab at Hasselt University, but also many other labs throughout the world, people are looking to nanotechnology, to nanomaterials. These are materials in the order of nanometers. 1 nanometer is 10 to the minus 9 meter. So for the cyclists among us, this is 0.00000000001 meter. One important class of these nanomaterials are the class of the so-called conducting polymers. These are polymers or plastics that are able to conduct electricity. This class of materials has been discovered by these three gentlemen in the 70s, and they received the Nobel Prize for it in the year 2000. With these materials, they could make ink, and when they apply this ink in a very thin layer in between of two electrodes, and you send electricity through it, you get magic, you get light. You can get this kind of white light, but you can also go to other colors. As an experimental professor, just look here, you can go to also orange. But even going further, if you use, for example, inkjet printing, you deposit these inks in very small droplets in various colors. Every pixel becomes a lamp, and you get a display. You can come to a color display, you can come really to a television, a so-called OLED television, the next generation of televisions. By using screen printing, you can apply these kind of smart inks, of smart paint, on various substrates. You can go to, let us say, glass, paper, but you can also go to textile. You can print on this light on textile. So it means, if you take a jacket, for example, you can print on this jacket with screen printing, and you can get a display on your jacket yourself. So your mobile phone can be really a part of your jacket. You can print also more electronics on your jacket. Imagine sensors to monitor your vital functions, or other sensors to get information from the environment. You really can get intelligent textile. You can be ambitious like our spin-off. They want to print on a jacket. They will print on a large surface. You can really print posters, meters square, that can give light, but can have also some animation on it. And another very nice realization of the spin-off Lumosa is this light-giving picture. It will only give picture when you put electricity on it. And you can imagine that this is a kind of electric painting, so coming very close to the dream of Picasso. Another lady, she's talking about another kind of paint, not a light paint, but a solar paint. So imagine that you have a brush and you use this paint and you put it on your walls, and these walls can become solar cells or solar panels. The question is, how does this paint look like? As an Italian, for me, this paint looks like this. Spaghetti with meatballs. So what are these spaghettis? Well, this here are our conducting polymers, and this here, these meatballs, they are what we call buckyballs. These are molecules that look like a football, but consist of 60 carbon atoms. Is this small? Yes, this is very small. Just to give you an idea, if you compare the size of this buckyball with a classical football, it's the same comparison as comparing a football with the Earth. So that gives you an idea what nanotechnology is all about. So with very small materials, you can do a lot of things. If now you use this solar paint, and you paint, for example, on plastic, you can come to solar panels that are flexible. Since plastic is transparent, you can also make solar cells that are transparent. And since plastic is light, you can integrate them in, for example, bags. But where do we need a lot of electricity? Well, we have more and more mobile electronic applications. And how often don't we have to hunt to find some place to plug into the grid? And How many times for our applications we don't have batteries? Well, if we would have these kind of solar cells integrated in these mobile electronic applications, they could charge themselves. You can go further in this imagination. You can play around to go to solar cells with different colors, with different forms. You can really make, if you want to send out a love message, you can make a heart that works as a solar cell. Imagine also for the architects that they can make smart windows. They can make windows of various colors, not only to look through it, but also to generate electricity. For the ladies in the summer, if they want to charge up their iPod, you have here a solar bikini. Solar paint brought on textile. But also, when we don't have a lot of light, if we are in a room like this, even here we can generate electricity. Imagine that you bring in these solar panels in this kind of jackets. While you're listening to a Pecha speaker, in the meantime there's some light, it will come on the solar panels of your jacket, it will charge your iPod, your iPhone. So you have really an electronic jacket. But printable electronics can go very far. Solar paint, electric light. We can also print really a computer processor just on plastic and bend it. You can make safety circuits on banknotes. Really there, the limits are the imagination. And this imagination brings me back to the master himself, Picasso, where I started the presentation with. And what did he say? Everything you can imagine is real. I thank you for your attention.